This is a drawing of two rectifiers. The one on the left is a vacuum tube rectifier, and sometimes it will have another element in it. And the one on the right is a solid-state rectifier. The parts of the vacuum tube diode on the left are the filament, and remember sometimes that's all we have, but we can also have a cathode, and we have a plate. Now the solid state one on the right, we have a cathode, and yes, they use K for cathode, and we have an anode. Now the solid state diode doesn't really require anything else for it to operate. But the vacuum tube diode requires that the filament be heated, and if we have a cathode, that filament is going to also heat the cathode. If we were to connect the appropriate voltages to each of these diodes with the polarity configured like this, nothing happens. In other words, if the cathode of both diodes is positive and the plate of the vacuum tube diode is negative and the anode of the solid state is negative, there is no current flow. However, if we were to reverse that, have negative on the cathode and positive on the plate and anode, we do have a current flow. So this is what is meant by a rectifier. It only allows current to flow in this direction when the cathodes are negative and the plate and anode are positive. Here are two full wave rectifier circuits. The top one is using a solid state, and the bottom one is using vacuum tube. Now they're both going to do the same thing and in the same order. If we have this situation on the secondary, the top rectifier in the solid state is going to conduct, and in the tube power supply, the rectifier that's on the left is going to conduct, and we're going to have this, and both are going to be charging their electrolytic capacitors. Now I'm only showing one in the tube power supply, but of course capacitor A would be charged also. Now the other scenario that we would have for this full wave rectifier would be this. When the bottom part of the secondary is positive and the center is negative, then the other diode is going to conduct and then charge the electrolytic capacitors. Now the side that does not conduct does have a polarity, and it is like this. In other words, the plate and anode is negative, and the cathode is positive, so that diode cannot conduct. So in this circuit, or in any circuit with a diode, the diode will conduct when the plate and anode is positive and the cathode is negative. So these two circuits, one being solid state and the other one being vacuum tube, functions the same way, or another way to say it is, they both have the same engineering architectural stamp. It's the same circuit, just the diode is of different technology, but it operates the same way. So another way to say this is, if you understand solid state, you can adapt to vacuum tube and vice versa. That is also true for more complex circuits like this solid state and vacuum tube receivers. Thanks for watching.